Hello, in this lecture we'll find out the area of the green triangle. In the drawing we have a quarter circle. Inside this quarter circle we have line segment PQ that is equal to 3 units, line segment AQ equals to 5 units in its length, and this angle APQ equals to 90 degrees. Our mission is to find out the area of the green right triangle AQO. So we'll focus on the yellow triangle APQ and we'll implement this yellow triangle, yellow right triangle, the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the yellow right triangle is AQ, therefore the square of the hypotenuse is AQ squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to QP squared plus AP squared. It again, according to the Pythagoras theorem, in the yellow triangle APQ, AQ squared equals to QP squared plus AP squared. So AQ equals to 5 units, therefore AQ squared is 5 squared, that is 25. And it is equal to QP squared. QP equals to 3 units in its length, therefore QP squared is 3 squared, that is 9, plus AP squared. Repeat again, according to the Pythagoras theorem, in the yellow triangle APQ, 25 equals to 9 plus AP squared. Here we subtract 9 from this equation, and we'll get that 25 minus 9 is 16, equals to AP squared. Here we'll take a root out of this equation, and we'll get that AP equals to the square root of 16. That is to say, the square root of 16 is 4. AP equals to 4 units. So, actually, ABO is a quarter circle, and you can easily complete the quarter circle to a circle, and then point O will be the center of the circle. And we have rule number 2 that states that whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. I repeat on rule number 2 again. A perpendicular from the center of a circle towards any chord bisects the chord. The center of this circle is point O. From the center of the circle we draw perpendicular towards chord BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord BC as M. So according to this rule number 2, the perpendicular OM from the center of the circle, that is to say from point O, bisects chord BC. That is to say, it divides it into 2 halves. The first half is BM and the second half is MC. And of course BM equals to MC. Okay, so whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. In this case, the perpendicular OM bisect chord BC, that is to say BM equals to MC. So we can implement rule number 2 in our drawing. From the center of this circle, that is to say from point O, we draw perpendicular on chord AP. Again, from point O, the center of the circle, we draw perpendicular on chord AP. So actually, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord AP is M. And according to rule number 2, the perpendicular OM bisects chord PA. And because of the fact that PA equals to 4 units, it means that PM, it is the first half, therefore it is equal to 2 units, and the second half is MA, therefore it will be also equal to 2 units. Okay. In the next step, we can say that PM equals to MA, therefore PM equals to 2 units and MA also equals to 2 units. In total, PA equals to 4, therefore PM equals to 2 units and MA equals to 2 units. We define the intersection point between perpendicular OM and chord A and line segment AQ as N. We define this angle PAQ as theta. So if we focus on the small right triangle AMN, this triangle AMN, this right triangle AMN, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the sum of the angles in any triangle. Likewise, if you focus on the big right yellow triangle APQ, this triangle, right triangle, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we will prove that the small right triangle AMN is similar to the big right yellow triangle APQ. Okay. The big right triangle APQ is similar to the small right yellow triangle AMN. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So, angle APQ in the big triangle, this angle, is equal to angle AMN, this angle in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. Repeat again. Angle APQ in the big triangle is equal to angle AMN in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta, is a common angle that belongs to both triangles, belongs to the small triangle and also to the big triangle. So we can say that angle theta equals to itself. It is a common angle that belongs to both triangles. Okay. So angle theta belongs to the big triangle, therefore we can define it as angle PAQ. Angle theta also belongs to a small triangle, therefore we can define it as angle MAN. So actually, calls to angle theta two different names. Repeat again. Here the equation means that angle theta equals to itself. Angle theta belongs to the big triangle, therefore we can call angle theta as PAQ, and angle theta equals to angle theta belongs to the small triangle also, therefore we can call it MAN. And it is actually angle theta. It is a common angle that belongs to both triangles, therefore angle theta equals to itself. Finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, angle PQA in the big triangle, this angle, equals to angle MNA in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. I repeat again. Angle PQA in the big triangle is equal to angle MNA in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually succeeded to prove that all three angles in the big triangle PQA are correspondingly equal to all the three angles in the small triangle AMN. Therefore we proved that those two triangles are similar to each other according to angle similarity rule. So I will write it down. So actually angle APQ, triangle APQ, that is the big triangle, is similar, this is the sign of similar, to the small triangle AMN, according to angle similarity rule. What is angle similarity rule? Angle similarity rule means that if you prove that all three angles in one triangle are correspondingly equal to all three angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. From the fact that those two triangles are similar to each other, we will conclude that PA in the big triangle over MA in the small triangle equals to PQ in the big triangle over MN in the small triangle, and it is also equals to QA in the big triangle over NA in the small triangle. I'll repeat again. From the fact that the two triangles are similar to each other, we will conclude that PA over MA equals to PQ over MN equals to QA over NA. PA equals to 4 units over MA equals to 2 units, and it is equal to PQ that is equal to 3 units over MN that is unknown, and it is also equals to QA that is 5 units over NA that is unknown. So I write it down. 4 over 2 equals to 3 over mn equals to 5 over na. Repeat again. We actually found out that 4 over 2 equals to 3 over mn equals to 5 over an. From this equation we will conclude, we will derive that 4 over 2 equals to 3 over mn. 4 over 2 equals to 3 over mn. Four over 2 is 2 and 2 equals to 3 over mn. We multiply this equation by mn and we will get that 2 times mn equals to 3, and finally we will divide this equation by 2 and we will get that mn equals to 3 over 2, that is 1.5 units. mn equals to 1.5 units in its length. I will write it down in the original drawing that mn, this line segment mn, equals to 1.5 units in its length. So actually, from this equation we will conclude that 4 over 2 equals to 5 over na. I write it down. 4 over 2 equals to 5 over na. 4 over 2 is 2 and 2 equals to 5 over na. We multiply this equation by na and finally we will get that 2 times na equals to 5. We divide this equation by 2 and finally we will get that na equals to 5 over 2. 5 over 2 is 2.5. So line segment na equals to 2.5 units in its length. I'll write it down in the original drawing that na equals to 2.5 units in its length. This line segment na equals to 2.5 units in its length. What is the length of line segment nq? For the drawing, it is very easy to see that qn equals to qa minus na. Again, qa equals to qa minus na. I'll write it down. Line segment qn equals to qa minus na. I'll repeat again. Line segment qn equals to qa minus na. So line segment qn equals to qa is 5 units, minus na. We just right now found out that na equals to 2.5. That is minus 2.5. In conclusion, we found out that qn equals to 5 minus 2.5, that is 2.5 units. Okay. Line segment qn equals to 2.5 units in its length. I write it down. Line segment qn equals to 2.5 units in its length. We actually know that any triangle can be blocked by a circle. Again, any triangle can be blocked by a circle, and therefore we can block the right triangle, AQO by a circle. So I'll copy the right triangle AOQ in a new page and we will block it by a circle. Okay. So actually, this is the right triangle AOQ that I copied from the original drawing. Now we'll block this triangle by a circle. So inside this circle, we have peripheral angle AOQ that is equal to 90 degrees. I'll write it down, peripheral angle AOQ equals to 90 degrees in its size. And we have rule number 5 that states that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. I'll repeat again on rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees rests on the diameter of the circle. Peripheral angle ABC equals to 90 degrees, therefore it rests on the diameter of the circle. That is to say, it rests on chord AC, that is the diameter of the circle. Okay. We can implement rule number 5 in our drawing. Right, because in our drawing we have peripheral angle AOQ that is equal to 90 degrees, therefore it rests on the diameter of the circle, that is to say QA is the diameter of the circle. QA is the diameter of the circle according to rule number 5. The diameter of any circle is 2 times the radius. So it is 2r, twice as long as the radius. So it is equal to 2r from one side, but from the other side, QA equals to 5 units according to what is given us in the question. And from this equation, we will derive that 5 equals to 2r. 5 equals to 2r. We will divide this equation by 2, and finally we will get that r equals to 5 over 2, that is 2.5 units. We actually found out that the radius of this circle equals to 2.5 units. Okay. In the next step, I will copy point N from the original drawing to our drawing. Okay. So this is point N that I copied from the original drawing. It is, we already found out that AN equals to 2.5. Here AN equals to 2.5. And line segment NO also equals to 2.5. Line segment NQ. Line segment NQ equals also to 2.5 units. Line segment NQ equals to 2.5 units. But we also found out just right now that the radius of this circle equals to 2.5. Therefore, Qn that is equal to 2.5 and it is located on the diameter of the circle must be the radius of the circle. Likewise, line segment NA that is located on the diameter of the circle and it is equal to 2.5 and the radius also equals to 2.5, therefore line segment NA is the radius of the circle. So we know that the diameter of the circle equals to 2r. Yeah, the diameter of QA equals to r plus r. Okay? And where is the center of the circle? The center of the circle must be at the touching point of the 2 radii. And the touching point of the 2 radii is at point N. Therefore, point N is the center of the circle. Point N is the center of the circle. We'll join points N and O by a straight line. what is the definition of line segment NO? Line segment NO starts from the center of the circle, that is to say from point N, and ends at point O, that is the point on the circle itself. This is exactly the definition of a radius. Therefore, NO is the radius of the circle, that is equal to 2.5 units. Okay, here we can write down that NO is the radius of the circle, that is equal to 2.5 units. In the next step, we'll implement the Pythagoras theorem on the right triangle OMA. So I'll copy the right triangle OMA in a new page and we'll implement on it the Pythagoras theorem. Side MA equals to 2 units. What is the length of side MO, or triangle MO? It is very easy to see from the drawing that MO equals to MN plus NO. Again, MO equals to MN plus NO. MN equals to 1.5, NO equals to 2.5, therefore in total MO equals to 1.5 plus 2.5, that is 4. So MO equals to 4 units in its length. So this is actually the right triangle OMA that I copied from the original drawing. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, this right triangle OMA, the square of the hypotenuse is OA squared, must be equal to the sum of the sources of the perpendiculars, that is to say it must be equal to MO squared plus MA squared. Okay. So OA squared equals to MO squared. MO is 4, therefore MO squared is 4 squared, that is 16, plus MA squared. MA is 2, therefore MA squared is 2 squared, that is 4. In conclusion, we found out that QA squared equals to 16 plus 4, that is 20. Now we take out of this equation and we find out finally that QA equals to the square root of 20 units. So I can write down in the original drawing that QA equals to the square root of 20 units. In the next step, I will copy the right green triangle AQO in a new page and we'll implement on this right green triangle AQO the Pythagoras theorem. So this is the right triangle AQO that I copied from the original drawing. QA equals to 5 units, and we just right now found out that AO equals to the square root of 20 units. According to the Pythagoras theorem, in this right triangle AQO, AQ squared, the square of the hypotenuse is AQ squared, equals to AO squared plus QO squared. So AQ equals to 5, therefore AQ squared is 5 squared, that is 25. And it is equal to AO squared. AO is square root of 20, therefore AO squared is square root of 20 squared, that is 20, plus QO squared. we subtract 20 from this equation and we get that 25 minus 20 is 5. So 5 equals to QO squared. We take out of this equation and finally we get that QO equals to the square root of 5 units. QO equals to the square root of 5 units. I write it down in the original drawing, and QO equals to the square root of 5 units. Now it is very easy to find out the area of this green right triangle AOQ. According to the Pythagoras theorem, the area of the green triangle the green right triangle AQO so here the square brackets is the sign for the area. It means the area of triangle AQO equals to the area of any triangle equals to the base times the height to the base. The height must create 90 degrees with the base over 2. So the base of this triangle will be QO, and the height to the base is AO. Why AO is the height to the base? Because AO creates 90 degrees with the base QO. This again equals to 90 degrees. So it is AO over 2. Repeat again. The base on the right green triangle AQO is QO, the height is AO over 2. QO equals to the square root of 5 units. AO equals to the square root of 20 units over 2. Repeat again. QO equals to the square root of 5 units. AO equals to the square root of 20 units over 2. We have the algebraic identity that the square root of A times square root of B equals to the square root of A times B. According to this algebraic identity, we get that the square root of 5 times square root of 20 is the square root of 5 times 20 over 2. 5 times 20 is 100, so inside the root we have 100 over 2. The square root of 100 is 10, and 10 over 2 is 5. So actually we found out that the area of the green right triangle AQO equals to 5 square units. I'll repeat again. The area of this right green triangle AQO equals to 5 square units. In the next step I will summarize the lecture. So in the drawing we have a quarter circle. You know that the length inside the quarter circle we have line segment PQ that is equal to 3 units, line segment AQ equals to 5 units, and finally this angle APQ equals to 90 degrees. Our mission is to find out the area of the green right triangle AQO. So first of all, we implemented the Pythagoras theorem on the right yellow triangle APQ. In the right yellow triangle APQ, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the source of the perpendiculars. The hypotenuse is AQ, therefore the square of the hypotenuse is AQ squared. It must be equal to PQ squared plus AP squared. Repeat again, according to the Pythagoras theorem, in the right yellow triangle APQ, AQ squared equals to PQ squared plus AP squared. Here QA is 5, therefore QA squared is 5 squared, that is 25. QA squared is 25. PQ is 3, therefore PQ squared is 3 squared, that is 9. PQ squared is 9, plus AP squared equals to 25 equals to 9 plus AP squared. We subtracted 9 from this equation, and finally we found out that 25 minus 9 is 16, so 16 equals to AP squared. We took a root out of this equation, and finally we found out that AP equals to, the square root of 16 is 4, and AP equals to 4 units. And then we know that OAB is a quarter circle. We can easily complete the quarter circle to a circle, and then point O will be the center of the circle. And you have the rule that whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. I repeat again on rule number 2. A perpendicular from the center of the circle towards any chord, bisect the chord. Point O is the center of the circle. From the center of the circle, that is to say from point O, you draw perpendicular on chord BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as M. So the perpendicular OM bisects chord BC according to rule number 2. That is to say, divide this into two halves. The first half is BM and the second half is MC. And the fourth BM equals to MC. So whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. In this case, the perpendicular OM bisects chord BC, that is to say, BM equals to MC. So we can implement this rule on number 2 in our drawing. From the center of this circle, that is to say, from point O, we draw perpendicular on chord AP. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and P and chord PA as M. Then according to rule number 2, the perpendicular OM bisects chord PA. Chord PA equals to 4. So if OM bisects chord PA, it means that the first half PM equals to 2 and the second half MA must be also equal to 2. Then we define the intersection point between perpendicular OM and line segment AQ as N. Then we define this angle as theta. So if we focus on this triangle, right yellow triangle AMN, this right triangle AMN, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. That is the sum of the angles in any triangle. Likewise, if you focus on the big triangle, the big right yellow triangle APQ, in this big triangle APQ, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Okay, then we proved that the small right triangle AMN is similar to the big right yellow triangle APQ. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. I'll repeat again. Angle APQ in the big triangle is equal to angle AMN in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta, is a common angle that belongs to both triangles. So angle theta equals to itself. So angle PAQ, that is angle theta in the big triangle, equals to angle MAN, that is also angle theta in the small triangle. They are both angle theta, so angle theta equals to itself. It is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle PQA in the big triangle is equal to angle MNA in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the big triangle are correspondingly equal to all the three angles in the small triangle. Therefore, we proved that those two triangles are similar to each other according to angle similarity rule. Again, the big triangle APQ is similar to the small triangle AMN according to angle similarity rule. What is angle similarity rule? Actually, angle similarity rule is that if you prove that all three angles in one triangle are corresponding equal to all three angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. Okay, and from the fact that those two triangles are similar to each other, we will conclude that PA in the big triangle over MA in the small triangle equals to PQ in the big triangle over MN in the small triangle, and it is also equals to QA in the big triangle over NA in the small triangle. I'll repeat again. From the fact that the two triangles are similar to each other, we conclude that PA over MA equals to PQ over MN equals to QA over AN. PA is 4, AM is 2, PQ is 3, MN is unknown, so we leave it as it is. QA is 5, and AN is unknown, so we leave it as it is. In conclusion, we found out that 4 over 2 equals to 3 over MN equals to 5 over N equals to 5 over NA. From this equation, we will conclude that 4 over 2 equals to 3 over Mn. 4 over 2 equals to 3 over Mn. 4 over 2 is 2, so 2 equals to 3 over Mn. We multiplied this equation by Mn, and we found out that 2 times Mn equals to 3. We divided this equation by 2, and finally we found out that Mn equals to 3 over 2. 3 over 2 is 1.5. So actually found out that this line segment Mn equals to 1.5 units in its length. From this equation, we will conclude that 4 over 2 equals to 5 over AN. Again, 4 over 2 equals to 5 over AN. 4 over 2 is 2, so 2 equals to 5 over AN. We multiplied this equation by AN and found out that 2 times AN equals to 5. Then we divided this equation by 2 and found out finally that AN equals to 5 over 2, that is 2.5. Line segment AN equals to 2.5 units in its length. What is the length of line segment NQ or QN? It is very easy to see from the drawing that QN equals to QA minus NA. Again, QN equals to QA minus NA. I repeat again, QN equals to QA minus AN or NA. QN equals to QA, that is 5, and NA equals to 2.5. So, in conclusion, we found out that Qn equals to 5 minus 2.5. 5 minus 2.5 is 2.5, of course. So we found out that Qn equals to 2.5 units in its length. We know that any triangle can be blocked by a circle. Again, any triangle can be blocked by a circle. Therefore, we block the right rectangle AOQ by a circle. So this is the right triangle AOQ that I copied from the original drawing, and we blocked it by a circle. In this right triangle AOQ, peripheral angle AOQ equals to 90 degrees, this peripheral angle, and we have the rule that any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. I'll repeat again on rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees rests on the diameter of the circle. In this drawing, peripheral angle ABC equals to 90 degrees, therefore it rests on the diameter of the circle. It rests on AC, that is the diameter of the circle. Again, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. We implemented rule number 5 in our drawing. In our drawing, we have peripheral angle AOQ that is equal to 90 degrees. Therefore, peripheral angle AOQ that is equal to 90 degrees must rest on the diameter of the circle, and therefore AQ is the diameter of the circle. Again, AQ is the diameter of the circle. Again, AQ is the diameter of the circle, according to rule number 5. The diameter of any circle is 2 times the radius, so it is 2r. And according to what is given as the equation, QA equals to 5. So from this equation, we derive that 5 equals to 2r. We divided this equation by 2, and finally we found out that r equals to 5 over 2, that is 2.5. So the radius of this circle equals to 2.5 units in its length. Then I copied point N from the original drawing, this point N, to our drawing. Okay, it is the same triangle. It is the same triangle. So I copied point N, AQN. This is triangle AQN, this is also triangle AQN. So I can copy point N from this original drawing to our drawing. So this is point N that I copied from the original drawing. We have already found out that line segment AN equals to 2.5 units, line segment AN equals to 2.5 units, and also line segment NQ also equals to 2.5 units. Here, line segment NQ also equals to 2.5 units. But we also found out that the radius of this circle equals to 2.5 units. AQ is the diameter. AQ is the diameter, and line segment QN equals to 2.5. And the radius of the circle also equals to 2.5 units. Therefore, QN must be the radius of the circle, because it is located on the diameter, and it is equal to 2.5, and the radius also equals to 2.5. Therefore, QN must be the radius of this circle. So, QN equals to the radius of the circle, that is equal to 2.5. Likewise, here, line segment AN located on the diameter of the circle, and it is equal to 2.5 units. But the radius of the circle also equals to 2.5 units. Therefore, AN must be the radius of the circle. So AN is the radius of the circle, that is equal to 2.5 units. Where is the center of any diameter? In the middle of the diameter, we have the center. AQ is the diameter, so in the middle of this diameter, there must be the center. Therefore, point N, that is the middle of the diameter AQ, must be the center of the circle. And also, we can say that we have the radius AN and we have the radius QN. The touching point of the two radii must be the diameter of the circle, that is to say, point N. Again, the touching point of the two radii must be the center of the circle. The touching point of those two radii is at point N, therefore point N is the center of the circle. Okay, point N is the center of this circle. We join points N and O together by a straight line. What is the definition of line segment NO? Point N is the center of the circle. Point O is the point of the circle itself. This is exactly the definition of a radius. Therefore, NO is the radius of the circle, that is equal to 2.5 units. So we can write down in the original drawing that NO equals to the radius of the circle, that is equal to 2.5 units. Then we implemented the Pythagoras theorem on the right triangle AMO. So I copied the right triangle AMO in the new page, and we implemented on it the Pythagoras theorem. Side AM equals to 2 units. What is the length of side MO? From the drawing, it is very easy to see that MO equals to MN plus NO. Again, MO equals to MN plus NO. MN is 1.5, NO is 2.5. Therefore, MO in total equals to 1.5 plus 2.5 is 4. So here we have, this is the right triangle AMO that I copied from the original drawing. By PT is a version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle AMO, we get that the square of the hypotenuse is OA square equals to MO square plus MA square. Again, OA square equals to MO square plus MA square according to the Pythagoras theorem. OA squared equals to MO squared. MO is 4, therefore MO squared is 4 squared, that is 16, plus MA squared. MA is 2, 4, so MA squared is 2 squared, that is 4. So in conclusion, found out that OA squared equals to 16 plus 4, that is 20. We took a root out of this equation and we found out that QA equals to the square root of 20 units. Here, QA equals to the square root of 20 units. In the next step, I copied the right green triangle in a new page and we implemented on this right green triangle AQA the Pythagoras theorem. AO equals to the square root of 20 and AQ, the opposite AQ, equals to 5 units. This is the right triangle AOQ that I copied from the original drawing. According to the Pythagoras theorem here by PT. The square of the hypotenuse is AQ squared and it must be equal to AO squared plus QO squared. AQ is 5, therefore AQ squared is 5 squared, that is 25, and it must be equal to AO squared. AO is square root of 20, therefore AO squared is square root of 20 squared, that is 20, plus QO squared. We subtracted 20 from this equation and found out that 25 minus 20 is 5, so 5 equals to QO squared. We took a root out of this equation and finally found out that QO equals to the square root of 5 units. Here, QO equals to the square root of 5 units. Now it is very easy to find out the area of the green right triangle, triangle AQO, that is the area that we are looking for. Okay? The square bracket is the same for the area. It means the area of triangle AQO equals the area of any triangle equals to the base of the triangle times the height over 2. The height must create 90 degrees with the base. So the base of triangle AQO is QO. The height is AO. Why? Because the height creates 90 degrees with the base QO. The height is AO over 2. Again, the base is QO, the height is AO over 2. QO equals to the square root of 5 units. AO equals to the square root of 20 units. Again, QO equals to the square root of 5 units. AO equals to the square root of 20 units over 2. We have the algebraic identity that the square root of A times square root of B equals to the square root of A times B. According to this trigonometric identity, we will get that the square root of 5 times square root of 20 equals to the square root of 5 times 20 over 2. 5 times 20 is 100. So inside the root we left with 100 over 2. The square root of 100 is 10 and 10 over 2 is 5. So we actually found out that the area of the green right triangle AQO equals to 5 square units. I repeat again, the area of this right triangle AQO equals to 5 square units. Okay, thank you very much.